Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Again, for you to take advantage of our contents, you can come into this horizontal toolbar, and then you can click the playlist and go into the numerical methods. So in this playlist of numerical method, you'll find that the collections of the videos that will teach about numerical methods from the first one to the last one. So that's the advantage that you'll find, which is you'll never find it in other ways, because you don't know how we used to name our lectures, and you don't know the number of lectures. But if you got the playlist of numerical method, you'll find the number of lectures, and you can find them. They'll be numbered from lecture 0 to lecture 10, for example. So again, we know that you'll enjoy our contents. You'll see the icons of share. You can click that in order to share the video link with other students through any social media. So my dear students, I know that now you have so many information. So I would like to take you now into today's session. So just usually we used to start with quick review. Okay, so quick review of what? Quick review of lecture 3. So in lecture 3, it has been titled as what? Problem solving, right? We have been solving problems, so problem solving. So in that problem solving, basically we say that we should be given, remember that, mean that initial value for all the problems, initial value of what? Of x is given. Is what is given. This initial value in most cases, we say that it is x is equal to something. So x is equal to, let's say, 2, or x not is equal to, maybe, in most cases it is 2. Okay? Then again, what did we discover? We discovered that we have to use the Newton-Raphson method, Newton-Raphson formula. And this Newton-Raphson formula, we taught you how we can derive this x subscript of xn plus 1 is equal to xn minus ffxn divided by what? F dash of 40 of xn. Very important formula. And again, we have been solving these problems in the number of 40, number of iterations. So number of iterations. With this number of iterations, you find that the output, so output of what? Output of first iteration, or iterations is what? Is the input of what? Of second iteration. This is very important concept when you be dealing with software, because that's what we'll be calling about algorithm. So simply this one is teaching us, later on will apply on learning algorithm in computers, algorithms of what? Of computers programs. Okay, computers program. Okay, computers program. So we have programs, computers programs in software. So this is an additional concept that I'm adding to in your mind. And then we left the homework to you, and this is all about correction. So let us do correction of what? Correction of homework 30. So it was homework 3, right? And this corrections was example 4. Example 4. It was a kind of the conceptual question, because let us read. So use the Newton-Raphson formula to find the root near 2 of the function, that one. So let me write. Use the Newton, because maybe Raphson method. Did you do the homework? If you have done the homework, let me know in the comment section below there. You use comment section to interact, to ask me questions, to give me feedback. just to challenge me, etc. So use the Newton-Raphson method. Okay, use the comment section, please. Go to the comments and then write something there to find the root. So to find the root, so use the Newton-Raphson formula. Find the root near to of the function, near to of the function, near to of the function what? Of the function. Our function is x power 5 minus what? The second term, excuse me about my voice, x power 3 minus 3x minus 5. X power 3, first term, minus what? 3x minus 5. So that the function, okay, x cubic minus 3x minus 5 is equal to 0. Correct to 2 decimal places. Correct to what? Two decimal places. Remember that our lecture 3 has been named as applications of what? No, the approximating root of the function by using Newton-Raphson method. That's the title for the lecture 3. But here, because we're focusing on that concept, so that's what we decided. This just let us name as problem solving, and it's conceptual. So this is the concept question first of all. So if you forgot, write that this is concept. Okay. So we'll be solving, and this will be our today's first example. Okay, solution. Whenever you are, so in previous lecture, I told you that the first step of solving this question, identify what? Identify the initial value of x, because the independent variable is x. Identify also what? Given function, which is f of x in most cases, and what? And the number of iteration. Those are the information which have been given in previous example. But let us read against this question and extract the required information. Use the Newton-Raphson method to find the root near to of the function x cubic minus 3x minus 5 is equal to 0. So first of all, the initial value x, which is, we call it x naught, is equal to what? It's near to, so the root is near to. So the initial value is 2. Then the given function, which we call f of x, is equal to what? Is equal to x cubic minus what? Minus 3x minus what? Minus 5. That's the function. But again, you need to know number 40, number of iterations. So I say that in example 4, the number of iteration is not given. So that the concept is not given. So here it's a concept. How many iterations are you going to do in order to find the response or to find the actual response? Again, you can pause a video for a time. Pause, it means that you can stop it, and then you can copy these steps, those 7 steps of registering yourself, and then we continue with the session. Remember, I say that if you have registered yourself, because we are doing only one registration in our lifetime. So if you have registered yourself, you have to skip these steps when we repeat, but you can take it into advantage in order to show somebody who did not register yet. So why are you subscribing? That's the very important questions. We have a vision to record more than 400 videos of ordinary diploma and make them free and make them into the public, and they'll be in the air so that every student or any students can access them at any time and anywhere. So it means that when you subscribe, you give YouTube permission to give you notifications of the new video, because we are adding at least one video in our official YouTube channel. Again, you can ask yourself that why this one? This is, we call it overcoat, right? So this is a coat for the engineers. So I'm teaching ordinary diploma engineers, and this is our dressing style. So even myself as your teacher who have to show you the way, I have also to show you the way to dress as an engineer. Does it make sense? Okay, thank you. So interact with me in the comment section as well as we continue. So the question now, how do we identify the number of limits? The number of iteration. How do we limit? Because we have infinite iterations. So you can do infinite iteration. How do we limit number of iteration in these problems in example 4? That's the questions that we have. That's the question I wanted you to think about. So the response for that question, whenever you find any question with asking you to approximate the root by using the Newton-Raphson method, then being given the initial value, then being given the function, then you are not given or you are not told how many iterations should you do. So whenever you find such kind of the situation, then you have to understand this simple principle. According to Newton and Raphson, these great mathematicians, they said, whenever you are solving the polynomial functions, if you are approaching the right root, okay, or the correct estimate, then you find the two consecutive iterations have the same value, right? So simply say that perform the response for that question. Perform iteration until you find two consecutive iterations. Two consecutive iterations gives us the same estimate. Same estimate of what? Of root of the function. And the good thing we have example 4. So you will see it. That's the technique. Okay? So if that's the case, okay, we got the second step. So the second step now, we say that we have to recall Newton-Raphson formula. Pause the video and write the Newton-Raphson formula on the piece of paper. Okay, the Newton-Raphson formula states that x of n plus 1, this is equal to xn minus what? Minus f of xn as numerator over f dash of 40 of xn. Okay, that's the Newton-Raphson formula. So that's the first step, second step. The third step, we say that now let me and you perform the first iteration. The first iteration. So for the first iteration, the value of n is 0. So suppose that this is equation 1. So if you substitute n is equal to 0 in equation 1, we get what? x1 is equal to what? Is equal to x0 minus what? f of x0, then divided by f dash of 40 x0. Okay? For x0. So here we have a second equation. Okay? So to perform the first iteration, we say that in that equation we have the value of x0. The value of x0 is known. The value of x0 we are given is equal to 2. And then what we don't know on the terms on the right hand side, we have to find what in. So find what? So find f of x0 and what in? F of x0 dash. Okay? To find that, we'll be using to find this. We say that. Okay, so f of x0 we substitute. F of x0 is equal to 2. We substitute into x0. So our function, which is f of x, it's x cubic. So we have x cubic, so instead of x we replace with 2. So it is 2 power 3 minus 3 times 2, then minus what? Minus 5. Minus 5. Okay? So this one, here we are looking for fx naught. 2 power 3 it is 8. 3 times 3 times 2 it is 6 minus 5. What the response? So 8 minus 6 it is 2. 2 minus 5 it's negative 3. Okay? So fx naught is equal to negative 3. Okay, we'll need the derivative of ffx in every iteration. So I will find it and will be recalling in different iterations that will be performed. Do you enjoy the beauty of basic engineering and scientific mathematics? Please tell me in the comment section there. Okay, so that is ffx naught. So to get ffx naught, dash ffx naught of the means the value of ffx for the first derivative of the function, then you have to refer the given function, which is ffx is equal to x cubic minus 3x minus 5. To find f dash of x, we have differentiated. We have differentiate every terms with respect to x. Okay, so minus 3, then d dx of what? Of x, then minus what? D dx of 5. Wonderful. So f dash of x in general, this is equal to what? So this is equal to, so if you differentiate this one, you get 3x squared minus what? If you differentiate x with respect to x, you get 1 times 3, it is 3. Then if you differentiate what? 5 as a constant, whenever you differentiate any constant, then you get 0. So simply, we have what? F dash of x is equal to what? 3x squared minus 3. So this one will make equation 3, which will be recalling in every moment. So you can use equation 3 to find what the value of the function we are looking here. So f dash of x naught, what's x naught? So f dash of x naught, this is equivalent to what? F dash of x is equal to 2, and this is equal to 3. So you have 2 squared minus 3. So this will make what? 3 times, so 2 times 2 is 4, 4 times 3 it is 12. Okay, 12 minus what? 3. The answer is what? Is 9. So we say that f dash of x naught, which is equal to what? What is x naught? X naught is 3, it is 2. Okay, this is equal to what? Is equal to 12 minus 3, it is what? It's 8. It's 9. It's 9. So f dash of x naught is equal to 9. So simply say that f dash of x naught is equal to 9. Is equal to 9. Okay? So if that's the case now, we say that we are looking for x1, so we have to substitute. So we go into the next step, which will be what? The first step. So the first step, ladies and gentlemen, we say that substitute what? Substitute x naught, ffx naught, and what? F dash of x naught into what? Into equation 2. So if you substitute into equation 2 is x1 is equal to x naught, which is 2 minus what? Ffx naught, or the value of x naught. Value of x naught is negative 3. Of what? Value of f dash of x naught, it's 9. So this is equal to what? 2. Negative is positive. Positive what? 3 over 9. So 3 over 9 is 1 over 3, right? So simply say that this will make what? 2. So x1 is 2 plus 1 over 3. So if you add, then you get what? 7 over 3. So 7 over 3, it's 2. It's 2, 1 over 3. So you can put in decimal places, or just you can leave the response there. So if you divide, you get what? 7 over 3 is 220. So 7 minus 6 it is 1. So 1 we add 0, it is 10. 10 over 3 it is 3. Okay. So 10 minus 9 is 1. We add 0, we get 10, and then we get 3. So we should do in how many correct to 2 decimal places. So you have to make sure that the value of the root of the functions is in 2 decimal places in every occasion. Okay? So this is x1 is equal to 2.30.3. Okay, so if you've joined me right now, you're only welcome. This is Olenjolai from Tanzania, a beautiful and excellent, the blessed country, eastern of the African continent. I'm very happy and I'm here to transform your way of thinking and also to attract you closely and to make you love the beauty of basic engineering and scientific mathematics. So we are in the middle of solving example 4, which is conceptual question, and we have done the first 4 steps. Then we have to keep on continuing. So I'll leave the question there. So if you join me right now, you didn't miss anything else, you can replay back this video and then see the previous concept that you have been focusing or we have covered. Okay? So this is the first, this is the value after first iteration. So, ladies and gentlemen, we go into the fifth step. The fifth step, you have to do it. Let I and you perform what? The second iteration. Okay, remember that we don't have an exact limitations of number of iterations, but we have the conditions, or we have the instructions. So perform the second iteration. So for the second iteration, say that n, the value of n is equal to 1. So if you substitute the value of n is equal to 1 in equation 1 there, then you get to it here you get x2 is equal to x1 minus what? F x1 of what? F dash of 40 x1. So this will make it an equation which is equation 4. We will call it later. Okay, so you see that the output of first iteration will be the input of second iteration. That's the goodness of numerical methods. And I told you, focus on this concept. We are applying this concept in many software or in a concept that we call algorithm. So just bear in your mind that whether you learn your modules, but we have a concept we call it algorithm. And we are using this process, and most of the computer applications and softwares are built or are made based on the iterations of performing the test, right? And that there in computer, we call it a guess. Okay? So keep praying. Maybe one day I can transform your mathematical understanding into the real applications of solving real life problems by designing or by using the computer software or by designing the computer application. Okay? So if that's the case, do you know x1? Yes, x1 we have this 2.33. Do you know f of x1? No. Do you know f dash of x1? No. Aha. So if that's the case, then you have a responsibility to find them. Okay? So find it. So f of x1 and f of x1 dash. Okay? Find f of x1. x1 is equal to 2.33. Should you have your scientific calculator. Then the given function is what? X cubic. So we have 2.33 power 3 minus 3 times 2.33 minus what? Minus 5. So use your scientific calculator. If you have lost your scientific calculator, don't worry, don't panic. In ODPT, we have an answer for that question. I would like to inform you that we have an online diploma or an online diploma library of Tanzania, online diploma library of Tanzania. So one of the items that we have in our library is original scientific calculator that we like just to equip our students in order to go far as well as they want to learn and as well as God will take them. So this is a original scientific calculator of Casio function 991. We have two, there's number 1 and number 2. So the extent of durability is different. For example, the Casio function 991, the first product, means the high quality product, it costly. It means that you can give a gift or you can order it in online diploma
in online diploma library of Tanzania. So you may order this scientific calculator in any regions, in any institutions or college that where you are in Tanzania, with only gift of 55,000 Tanzania shillings. But you have also number 2, which is low quality. But also it can work, but it won't be durable more than 3 years. This one will give you a guarantee that if you keep it well and follow the instructions of the manual, you may use it yourself and then leave to a young brother or young sister. So it means you may use it in more than 3 years. But so the number 2 is cost only 35,000 Tanzania shillings. In case you want to order this scientific calculator for yourself or for your young brother or young sister, then just send your order or send just an SMS that is Olenjolai or Engineer Olenjolai. I want you to buy Casio Function 1, the high quality of Casio Function 991. If you send a message, then we'll read your message and call you back. Don't make a call because in most cases my phone is offline when I'm teaching, and I'm teaching more than 30 subjects in a week. Okay, so thank you for making an order. You're welcome. But remember that is without your transport costing. Transport costing, it depends to the place where you are, but it's not high. Doesn't mean that you spend, according to my research, you may spend almost about 10, it's not more than 10,000. Okay? Okay, so take your scientific calculator and then let us do the computation. So there we have 42.33, and then we put power 3, and then we have to subtract with the product, 3 times 2.33. Okay, so we are doing live computation. Tell your neighbor Olenjolai is doing live computation. So the response here is 0.6593. Then we have to find f dash of x1, which is 2.33. What is x1? It's equation what? Equation 3. So it is 3, we have 2.33 square minus what? Minus 3. So use your scientific calculator. So you've been given 2.33, then you have to square. And after squaring it, you have to multiply with 3. Then you have to minus with 3. So you get what? So you get 13. Get 13 to 867. Okay. So now we have x1, x2. So we go into the 6th state. So the 6th state, we say that substitute x1 and also substitute ffx1 and what? fx1 and the f dash of x1 in what? In equation 4. In equation 4 above. Equation 4 above. Okay? Okay, so let us make a substitution. So we have x2 is equal to what? x1. What's x1? It is 2.33. Then we have minus ffx1. What's the ffx1? ffx1, the value of ffx1 is what? 0.6593 divided by what? 13.2867. So let us find the value of x2 in 2 decimal places. Okay, so you have 0.6593 divided by the response. So you have 2.33 minus the answer. So the answer here is 2.28 in 2 decimal places. So you finish the second iteration, and the answer of the root of the function is 2.28. So the next equation, we know that our limit is we have to do the iteration until we find the 2 consecutive values of root of the function are closely equal. So you can compare. Is 2.33 equal with 2.23 with 2.28? No. The difference there is 0.5, because if you take this one minus this, for example, if you take 2.3 minus 2.28, so 13 minus 8, so so there we borrow 1, 13 minus 8 is 5, then we have 0. So we have a difference of 0.05. This is still what? A great difference. So it's not a correct estimate of the root of the given function. So let us do the fairly perform what? The third iteration. So that will be what? The 60. So this will be the 7th step, right? The 7th step. 7th step, we say that let us perform what? Let us perform the third iteration. Third iteration. Okay, the third iteration. So for the third iteration, the value of n is equal to what? Is equal to 2. So you have to refer what in question 1. So if you substitute the value of n in question 1, you have what? x3 is equal to x1 minus ff(x1). Then over what? This over ff(x1 dash). Okay. So that's the formula. So this will make what equation what? Equation 5. So on the right hand side, we know this is x2. So the output of the second iterations will be the input of the third iteration. So we find that x2 is 2.28. Do we know ff, and this is ffx2, excuse me, do this correction, ffx2 and ffx2. I'm sorry, I see you there, say, sir, I should substitute the value of n is 2. So you made a mistake. Yeah, I agree, I made a mistake, but I thank God he has reminded and showed me, and I made a correction. So let us continue with the business. So then, if that's the case, you say that let us find out the value of ffx2 and the value of what f dash of x2. How we find it? So we're looking at the value of ffx2. So what the value, what is x2? X2 is 2.28. What the given function is x cubic. So we substitute 2.28 by power 3 minus what? Minus 3, 2 times what? Times 2, 2.28 minus 5. Okay? So if that's the case, you say that ffx or ff2.28, this is equal to what? So take your scientific calculator. So insert, we have 2.28, then power 3, then we subtract with what? 3 times what? 2.28. Then minus what? Minus 5. The response is what? Response is 0.01, then 2, 3. Remember, this is a value of the function. This is the value of the function. It's not the root of the function. So the value of the function you can put in any decimal places. So then we are looking ff dash of what? Of x2. X2 it is 2.28. So what is our derivative function? Our derivative function is equation 3. It is 3x squared. So it is 3 times what? 2.28 power what? Power 2 minus 3. Okay. So in this case, you say that, okay, fine. So if that's the case, we have 3 times what? Times 2.28 squared minus what? 3. So the response is what? Is 12.59. This is the value of the first derivative of the function 52. So 12.5952. So then we go to the 6th step now, ladies and gentlemen. For the 6th step, you say that substitute the value of x2, the value of what? ffx2, and the f dash of x2. In what? In equation 5.
So if you substitute, we will get x3 is equal to 2.28 minus f of x2. F x2 it is what? 12.5952 divided by what? F dash of x2. So f dash of x2, oh, excuse me. So you have f of x2, and f of x2 it is what? It's 0.01235 over what? Over 12.5952. So you have 0.01235 over what? 12.5952. Then you have what? 2.28 minus the response. So this will make your 2.279. But remember, the value of root should be in 3 decimal places. So if you estimate now, so you'll find that this is 2.28. Wonderful. So x3 is equal to 2.28. Should we stop? Yeah, why? Because the value of x2, which is the output of the second iteration, is equal to the value of x3, which is the root that you obtained after performing the second iteration. So there you have to stop, because if you continue, if you go, why should we stop? If we perform the first iteration, we'll get the same value of the root to be 2.28. If you go also the next iterations, the 51, the 61, the 71, the root will be the same. That's why we have to stop. And even the computer programs, that's how we used to perform. The real-life applications of numerical method is in executions of computer programs, in writing algorithms of computer programs, even writing algorithms of different problems, but especially computer applications uses, or computer applications use numerical method in executing a program. So we say that, so you have to note. So you say that the root of second iteration is equal to the root of the function, the given function in what? In third iteration. In third iteration. So for this case, it means that we found x2 is equal to x3, which is equal to 2.28. So stop performing what? Stop performing iteration. Stop performing iteration. So therefore, because you've been asked to find out, use the Newton-Raphson method to find the root near that one. So you say the root of x cubic minus 3x minus 5 is equal to 0. Near to 2 is 2.28. That's the final response. Okay, that's the final response. So I believe that you've enjoyed this example. Isn't? Tell me in the comment section, please, if you've enjoyed it or not. So for that case, let me now give you example 5, which is homework 5, homework 4, and this part we used to call it practice it. So we are giving you the question of the same concept, but if you have never learned it in its concept, okay? So in this question said that the question said that the root, no, this question is from the Understanding Mathematics, written by Professor Shayo,
who has been the mathematics professor in Tanzania, page 519. Okay, so this example we say that refer understanding what? Understanding math. Okay, understanding math. So the question states that starting with x naught is equal to 2, starting with x naught is equal to 2, calculate an approximation. Calculate an approximation. Calculate an approximation of the root. Calculate an approximation of the root of the function f of x is equal to x squared minus 2x minus 1 correct to 2 decimal places. Correct to 2 decimal places by using Newton-Raphson method. So you see the same question to be asked, but it does not state about how many iterations should you do. Starting with x naught is equal to 2, calculate an approximation of the root of the function f of x is equal to x squared minus 2x minus 1 according to 2 decimal places by using Newton-Raphson method. Then you are not told how many iterations should you perform. So you know the technique that I have told you. That's why that I don't want to waste your time while I have built the foundation of how you can deal with those questions which does not mention a number of iterations. So I believe that right now you can solve that question and you'll enjoy and you'll find that basic engineering mathematics and basic scientific mathematics for ordinary diploma is not a difficulty subject. So ladies and gentlemen, if that's the case, again, we can refer some of your past papers, some of the past papers of the Dar-es-Salaam Institute of Technology to see questions, some questions of numerical that asking you to estimate or to approximate a root of the function. So this will make example 6, and you have to refer. So I have another example here for you. So refer, so I told you that we need past papers. So you see this past paper, Dar-es-Salaam Institute of Technology, Departments of General Studies, Complex Numbers, Numerical Method and Series, end of semester supplementary examination, and then towards August 2017. So refer DIT supplementary final exam, okay, of 2017. Question 1, Roman C. It was asking you a question about the Newton-Raphson method. So the question states that state the two situations where the Newton-Raphson method Okay, the Newton-Raphson method may fail in approximating what? A root of a function. A root of a function. So if you solve this problem, you have 4 marks. State the 2 situations where Newton-Raphson method may fail in approximating a root of a function. Very important questions. If you refer in lecture 2, we answered this question. The answer for this question is taught in online diploma polytechnic Institute of Tanzania and square bracket Olenjolai, lecture 2 of numerical method, but possibly that you have forgotten, or you saw that we were teaching you concepts that never appear in exam. Solution. So state the 2 situations where the Newton-Raphson method may fail in approximating a root of a function. So the 2 situations meet the 2 conditions. Simply means the questions ask you the 2 conditions. So we say that in the 2 situations, so the first one, we say that the given function, whether polynomial function or exponential function, the given function should be what? Should be, so each condition or each situation we have 2 marks. The given function should be differentiable. So the given function should be, it means that should be differentiable. It means we should be able to differentiate the given function. It means that mathematicians should be able to differentiate the given function. Okay, the given function uses what? Newton-Raphson method. That's the first condition. The second condition, we say that the initial value. So I say that the second condition for you to use the Newton-Raphson method on approximating the root of the function, we say that the initial guess or the initial value, okay, the initial value of root of the function should exist. In most cases, for you, ordinary diploma is given, except in few cases where that is not given. So you say the initial value means the x naught. The x naught means the x naught, this we call it the closest, or one of the closest value to the actual root of the function. One of the closest value of the actual root of the function. So that one should be given in most cases to simplify your life, as what you have seen in example 1, from example 2, 3, 4, and even example 5 there, that the initial value is given. So for example, if this given function f of x is equal to x squared minus 2x minus 1, is it differentiable? Yes, the answer is yes. Are you given the initial value? Yes, it is x2, because x2 it's one of the closest root of the function. It's one of the closest value to the root of the function, right? The root of the function. But this condition sometimes, in some cases, it's not given. In some cases, it's not given. We have a proof of that. Okay. So simply, these are the 2 conditions. So you have score 2 marks. 2 marks. You see, the examinations life in ordinary diploma is simple. That's why I say that I have to omit this stress, because I know that in most cases you are very stressed with numerical methods and series, and especially that you are very stressed with test 1, test 2 and final exams of numerical methods and series. So I have to omit that stress first. After I omit that stress first, then I will take you to think outside of the class. Think outside of what? Think outside of the class. Okay, so if that's the case, then we have again another conceptual question. Okay, another conceptual question. As I say that there are some cases where the initial value of the root of the function is not given. So I want to deal with that and give you a technique, because here, this is the home of understanding. Okay? So this is example 7. So example 7, this is, you have to write it a conceptual question, because the question which is kind of deviating the second word, deviating the second condition. So refer DIT, is this the final exam? Yeah, end of semester examination. So DIT, final exam, end of semester examination, of which year? Of 2015. That's 2015. Question what? Question 3B. So it is one of the questions in section B. This is the print. So this is the past paper that I have. Okay? So this is the past paper. So I'm trying to see that if you see it, but actually this is the past paper. Because of the reflections of light, the paper itself is white, so there are some challenges for you to see it. But this is the past paper. So the question says that find the real root of the function find the real root of the function. Find the real root of the function, and the given function is f of x is equal to e power x, so it's exponential function, minus 3x by what? By using Newton-Raphson's method. Newton-Raphson method, corrected to 4 decimal places. Corrected to 4 decimal places. Corrected to 4 decimal places. And if you do that, you have 4 marks. So you have to do so many practices, because this is the one of the long questions. 4 iterations, one of the long questions. So you should be capable to solve these questions quickly as possible. So if you do too much practice, then you know what to do the next step to be accurate, because this is kind of numerical computation. So the questions read that find the real root of the function f of x is equal to e power x minus what is 3x. So you should not confuse it there about the function. The function is exponential. This we call it natural exponential function. This is polynomial term. But using Newton-Raphson method, correct to 4 decimal places. Correct to 4 decimal places. Correct to 4 decimal places. So solution. I will not solve every part of these questions. I will. If you check the questions, it's difficult. Why? Because you have been given a function, but you are not given the initial condition. And also you're not given the limit of number of conditions, number of iterations. So in example 5, I told you how can you deal with a questions which does not state the number of iterations that you have to perform. So I won't repeat it again. So you use the same concept. The challenge in this question is how can you identify the initial value for that given function. All right? Are you ready for that? So let us go into solution. So the solution always starts from the fundamental concept I told you. The first step, we say that identify what? Identify the given what? Identify the initial value. Identify the initial value, which is equal to x naught. Identify given function. Given function, and what? Number of what? Number of iterations. Number of iterations. Okay? So identify the initial value. So the initial value for that case, which is x naught, is unknown. So it's unknown. Given function. Are you given a function? Yes, it's f of x is equal to e power x minus 3x. Minus 3x. Is it differentiable? We'll see. The number of what? Number of iterations. Number of iterations. Number of iterations is unknown. That's right. Because this is what you're looking at. It's unknown. Okay? So you don't know the number of iterations that you should perform, and also you don't know the initial value. Can you use the Newton-Raphson method to solve such kind of a problem? It depends. It depends to the level of your understanding. You may recommend that I cannot solve it because the initial value is not given. That's not the case. There are some other techniques of mathematics that we taught you in previous subjects on how you can deal with such kind of a problem. So you have two problems. X naught is unknown, number of iterations is unknown. But I have taught you how you can deal with the questions which does not say the number of iterations. The problem is what x naught. So I will teach you how you can find x naught of that function. So we go for the second step. The second step, we say that find out the first derivative of the function. So you're being given f of x is equal to e power x minus 3x. Okay, f dash of x is equal to what? We differentiate e power x d what? dx 3x. Okay, so f dash of x d dx, you differentiate e power x with respect to x. The answer is e of x minus 3. So this is the derivative function, and this is equal to equation 2, while this is equation 1. Remember that in our performing iterations we need these equations. So now let us deal with another problem, or the hardest problem, step 2, the third step. Find what? So find the value, find the initial value. Find the initial value of what? Of closest root. Closest. Find the initial closest root. Closest value. Find the initial closest value to the root of the function. In simple language, you have to think how can you find x naught. So here you have to listen, because this is all about dealing with functions and using the simple computations, and this is all about numerical. Remember that. This is what you have to note. The root, so you say that when a root of a function is substituted in its function, then the value of the function is always 0 or close to 0. What does it mean? Listen. For example, let me give you a live example. In example 5, in example 4, we have given a function f of x is equal to x cubic minus 3x minus 5. Did we find the root? Yes, this root is sorting. It's root. So root of this function is 2.28. What if we substitute in this function? Instead of x, we put 2.28. This will make it 2.28 power 3 minus 3 times 2.28 minus 5. Okay? So use your scientific calculator to find the value there. Because if you can manage to find that, and you understand that rule applies for all the functions, and then now we can have our initial base or initial value close to the root, to the exactly root of the function. So let me write it correctly. If you are looking at the f of 2.28, this is equal to 2.28 power 3 minus 3 times 2.28 minus 5. So take your scientific calculator and do the numerical computation. It is 2.28. Then this one we have to square, and we have to subtract with 3. With open bracket 3 times 2.28. Okay, and then we have to minus subtract with 5. Is that the function? Wait. I had it 2.28 power 3 minus 3 times 2.28 and then minus 5. Yeah, right now, before I did a mistake. So the answer for this case, the f of 2.28 is equal to 0.012352. Okay? So remember that this is the approximate root of the function. For that case, you say f of 2.28 makes the given function to be closely equal to 0. That is, and so you say that this rule, so this rule or this fact apply for the root of all real function, real function. So if that's the case now, we have our given function, which is f of x is equal to e power x minus 3x. So it means we have to guess. It means that we have to try different methods to find the value of x which make these equations to be equal to 0. Okay? So it means that f of x naught, which is initial value, will make e power x naught. If you have e power x naught minus 3x, this is equal to what? Make equal to 0. So you say e power x naught is equal to 3 what is x naught? Or you say that e power x naught minus 3 x naught, this will make equal to what? To 0. Okay, so if you'll be using the technique of making the survey, it may be a little bit challenge. Okay? But we can let us try. Let us try. So e power x naught is equal to what? 3 power x naught. So how can we make x the subject? X not the subject. So for example, if you say that, it's a little bit challenging. Because if you apply ln, for example, so it will be x naught ln of e is equal to what? Ln of 3 plus ln of x naught. So it means you'll find that we have x naught minus ln of x naught is equal to ln of 3. So it's a little bit challenging. How can you find x naught? So because of this challenge, that's why we need Newton-Raphson method. So the technique right now, alternatively, so you say that this is the challenge. Alternatively, we as mathematicians, always you have to think about alternative method of solving a problem. Okay, so you say that alternatively, so this is about steady state, and this rule, so we are in force state. So the fifth step, we say that determine the initial value, the value of x naught, by using try, we write in capital letter. So try and the error method. So we'll be using try and error method. We'll be trying different values of x naught, which will satisfy, okay? So to find it, determine the value of x naught, determine the value of x naught by using what? Try and error method for the given function for e power x minus what? 3x is equal to 0. So, if that the case, when you say try and error, you have f of x is equal to what? E power x minus 3x. But remember we say that f of x naught will make e power x naught minus 3x is equal to 0. So you can try. Try with f of x1, start with positive 1. If you start with 0, you can start from 0, let's say. Okay? So this e power 0 and 3 times 0. So e power 0 is equal to what? And a number power 0 is 1. Okay, 3 times 0 is 0. So the answer is 1. So for that case, it means f of 0 is not equal to 0. It's equal to 1. Okay, so this is first try. So you go for the second try. That's why I told that. That's why the title of lecture 4 is solving conceptual questions like this. Okay? So we are going to try for f of positive 1. F of positive 1 will be e power 1 minus what? 3 times 1. So e power 1, this is a certain value, minus what? 3. So to get the value of e, so place alpha, then e. Okay, so you get 2.718, say 2, minus 3. So you say that f of 1 is equal to what? To this one, minus 3. So at least this is approaching. It's negative 0.28 1, 7. Okay? At the second try, but again, it's not equal to 0. We go for the third try. The third trial, let us look the value of ff negative 1. So this will be e power negative 1 minus 3 times negative 1. So this will make e power negative 1, then minus what? Plus 3. So this actual will not be equal to 0 because 3 plus e power negative 1 means 1 over e. So 1 over that one. So the answer will be greater than positive 3. So this is just failed. So negative 1, okay? So we go for ff2. ff2 it is e power 2 minus 3 times 2. So e power 2, 3 times 2, it is 6. So you know the value of e. It means that 2.7182 power 2 minus 6. Or you say that alpha e square then minus 6. So this value, you'll find that the value is 1.389, which is not equal to 0. So you can try for ff negative 2. Actually, the last try. And then from those trials, you pick the closest value of the root, because we are not finding the actual root, but we are finding what? The closest root. Because for the previous, for example, 4, if you do remember, the exact root is 2.2, or the approximate root is 2.28. But the initial value, or the initial root, remember that, let me just see, let you understand. The example 4, x naught, it was 2. Root, so x, which is equal to approximate root, is equal to 2.28. If you substitute ff2 in the given function, so you have x cubic. So x cubic is 2 power 3. Then 3 what? X times 2 minus what? Minus 5. So this will make what? 8 minus 6 minus 5. So 8 minus 6 is what? 2. 2 minus this one is equal to what? It's negative 3. Isn't it? Yeah, negative 3. So you see that when you substitute 2, the value is negative 3, but it was the closest value, but it's far, because 2 and 2.8, there's a range of 0.28. So let us do the trial, which will be the first trial. The first trial. First trial, try ff negative 2. So it is e power negative 2 minus 3 is negative 2. This will make your e power negative 2, it is 1 over e square plus what? 6. This one, no need to evaluate, it's not equal to 0. Therefore, from the first trial, second trial, first trial, the closest value to 0 is ff1. So you say therefore, the initial close value to the root of e power x minus 3x is 1. For that case, x naught now is equal to 1. Then we've already solved the challenging part. So now, because you have x naught, you may perform the first iteration, and then you perform the second iterations. Then you compare the roots of the function. If they are not equal, you have to perform the second iterations. Then you compare the root of the functions for the root of the functions after performing the root of the function of the second iteration and the root of the function of the third iteration. If they are close or if they are equal, then you stop. Then that should be the approximate root of a given function e power x minus 3x. That's how we deal with all problems like this, in which the initial value is not given. So you have to use the trial and error method. In case a function is complicated, you may also get a company of use of your scientific calculator. That's the technique. I want to tell you, even myself, because I learned numerical method during my Form 6 education so many years, more than 10 years ago, I didn't know how to deal with this question. When I was preparing myself in order to teach ordinary diploma about this concept, the Holy Spirit revealed this concept and this technique. Again, in case that you want to do or to solve more questions about numerical method, I recommend that you should get this book called Pure Mathematics 1, very important book. And the concepts of numerical method is discussed by using Newton-Raphson method and even some other iterative methods. Is discussed in page, just go into the table of contents, then page 400 if I'm not mistaken. So vectors and further topics of geometry, further topics in coordinate, your key, iterative method. So it is chapter 24 of Pure Mathematics 1 by J.K. Backhouse and S.P.T. Horsworth. So it's chapter 24, which is stated as iterative method for solving equations. This topic is found in page 466 of this book. It's introductions and iterative method for finding square roots. Those are the parts. You learn about further iterative formula. You learn about iterations, the test for convergence. You learn the last concept, you learn the Newton-Raphson method that we've been teaching you. The good news, you may order this book in online diploma library of Tanzania with a very affordable price compared to the price of the local shops. This is just a gift for we are giving our free will in thanksgiving to God, and we are giving Tanzanians gift. So we want to give this gift to ordinary diploma students in order for you to practice and to do more questions about a particular concept. I use this book as a reference book. And even your teachers also use this book as a reference book, so even if they don't tell you that they are using this book or they are getting those questions from this book. This is a cross-cutting book. It is used for ordinary diploma mathematics, engineering mathematics. It is used also for advanced, to learn advanced pure mathematics, right? It's in rare cases that you can use this book to learn basic applied mathematics. So you may order this book with only a gift of 30,000 Tanzania shillings. And in case you want to order this book or you want to order the original scientific calculator of Casio function 991, don't hesitate yourself to send to us an SMS of your order through the telephone number written there on the blackboard 0759745331, and then we'll make a call and accomplish this business so that to equip our students, because we want you to go far as God will take you on understanding these different concepts of engineering, engineering and scientific mathematics in order to apply on solving real life problems. So ladies and gentlemen, this is the end of lecture 4. I feel from my heart that I have been emptied on, a little bit emptied. I have emptied myself to you with teaching you all of these 7 examples and the concepts itself. It doesn't mean that this is all I know about numerical method, about Newton-Raphson method. No, we still have some other 2 applications later. That will consist lecture 5, lecture 6, and possibly lecture 7. We'll be focusing again. We'll be still focusing on numerical method. So I would like to invite you to join me in the next lecture. We remind you to subscribe in order to get notification. We remind you also to share these contents and to watch this video several times as well as you can. And we remind you that to challenge yourself, where are you going to use this information to solve real life problems? And I have given you a directions that we use this technique on designing the computer software. Okay, the software of the computers that giving computer instructions on what to perform, or giving the hardware electronic system the instructions of what to perform, how to perform a particular task. For example, we use this one to design the Word applications or Excel applications or PowerPoint applications, any applications that you know in the computer, even the applications of the YouTube. Also, it is used these concepts of numerical methods, which we call the iterative method, or just it means using the guesses, initial guesses, as the input, and then the output just become the input of the next iteration. Ladies and gentlemen, this is the end of this session of lecture 4, as I said. Remember also to ask a question in the comment section there and give me feedback, give me testimony. How did you find this material useful for you? And tell us you're doing this content from which institutions, which level of study are you, which class are you, first year, second year, third year, ordinary diploma. Okay, are you doing diploma in engineering or diploma in science? Tell us in the comment section, please. Don't keep quiet. Don't think that we don't read comment section. We are reading comments from all our students, and we are visiting every video to see the comments that our students have put. Asking questions also, and they share with me some challenges that we are used to encounter on learning Newton-Raphson method. Again, the last information that I would like to share with my beloved students of ordinary diploma. You may offer your feeling Thanksgiving. We are offering, first of all, why am I offering this content free? That might be confusing questions to many Tanzanians, because I can make a lot of money from this through this program. But this is my feeling Thanksgiving to my God. I'm offering my feeling Thanksgiving to my God, who has given me a gift of teaching, and who has given me just the understanding of mathematics. It means my school teachers or my university teachers, they have a very small contributions on what I know about all of this stuff. They just build the foundations in me, but I thank God because He has taken me extra miles. So in case you yourself also want to offer your feeling Thanksgiving of any amount of money, of any material, we need microphones, we need light, we need batteries. We are using electricity, we're using the internet. So we have a very high running cost. So you may offer your feeling Thanksgiving in order to support this program in such a way that all the lectures, because we have a vision to record more than 400 lectures to train and incubating ordinary diploma students of present and future generation. You may offer your feeling Thanksgiving right now from your heart or even later on. And remember that we receive, because it's an offering, God receives our offering, even the small offering that you think it is meaningless to you. But if you offer it by faith, God will do great things to you. For example, 50 Tanzania shillings is acceptable. 100 Tanzania shillings is acceptable in all digital. 10,000 Tanzania shillings is acceptable. 25,000 Tanzania shillings is acceptable. 1 million and a feeling Thanksgiving of 1 million is accessible in OT, in Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Because our eyes and your eyes should focus to God, who is a provider, who is a source. Because my God, the God of Abraham, Isaac, and Jacob, is the founder of Online Diploma Polytechnic Institute of Tanzania, and is a sponsor. He's the one who is paying for the running cost, for everything, for every cost, and even for my own cost for these programs, and make it happen, because I know that when I'm doing these programs will be building up in the mind and solving real life problems of so many ordinary diploma students. My God, the God of Abraham, Isaac, and Jacob, will be given all the glory and honor. Will give Him all the glory and honor. So give my God all the glory and honor. Don't give me, because it's my God who is in me, who is teaching you. Okay? So remember that the principle, and that is the fact we have to remember everything. So you may send your feeling Thanksgiving. So that telephone number 0759745331. Registered name is Olenjolai TAYAI. After that, then you enjoy the beauty of basic engineering and scientific mathematics. So this is Olenjolai from Tanzania. I love you so much. May God bless you. I'm always praying for you. I ask you to pray for me. So let us meet in the next lecture, which is lecture 5, and keep enjoying the beauty of basic engineering and scientific mathematics for the rest of your life. May God bless you and protect you until we meet.
Mungu ibariki Tanzania, dumisha uhuru na umoja.